Next, I'm going to explain you about the perpendicular axis theorem. So for understanding the perpendicular axis theorem, suppose this is your body. Suppose I take a body here. This is my rigid body. Okay, so this is the point of the center mass. I know the moment of inertia about the x-axis. That is, I'm taking as Ix. And the moment of inertia about the y-axis also I know. That is, I'm taking as Iy. Then I want to find what will be the moment of inertia about the z-axis. So z-axis is perpendicular to this. So or I can draw in 3 dimension. It is here. I suppose I don't need as this is I z. Moment of inertia about the z-axis. According to this perpendicular axis theorem, it says that if you know the moment of inertia about the two perpendicular axes, then the moment of inertia which is perpendicular to both the axes will be given by the moment of inertia about the z-axis is given by nothing but Iz equal to Ix plus Iy. That is the moment, that is the perpendicular axis theorem. So here, if we donate the moment of inertia about the z-axis, we donate by C, and this is nothing but A, and this is nothing but by B. So we get C equal to A plus B. So here, if I consider a typical mass delta m at point whose coordinate with respect to OX axis, as I take a point here, the mass is delta m, and the distance from the x-axis I'm taking as x, and the distance from the y-axis I'm taking as y, small y. Then the moment of inertia about the x-axis will be nothing but summation delta m y square, and the distance from means the moment of inertia about the y-axis will be nothing but summation delta m should be x. It will be summation delta m z square, or it should be summation delta m x square. So this will be summation delta m x square. This is summation delta m x square. So the moment of inertia about the x-axis is summation delta m y square, and moment of inertia about the y-axis will be summation delta m x square. So now we'll try to find what will be the moment of inertia about the z-axis. That is nothing but summation delta m op square. So we are trying to find this perpendicular distance op square. So this is my O. So we are trying to find what is op square. So op square is nothing but the square root of x square plus y square. So here we get the distance. Op square is nothing but op is nothing but square root of x square plus y square. So op square will be square y square plus x square. So if I separate this, we get summation delta m y square plus summation delta m x square. So this is nothing but moment of inertia about the x-axis, and this is nothing but the moment of inertia about the y-axis. So we get A plus B. So that shows that moment of inertia about the z-axis is equal to nothing but the moment of inertia about the x-axis plus the moment of inertia about the y-axis. So that is the perpendicular axis theorem. So if we know the moment of inertia about any two perpendicular axes, then we can also find the moment of inertia about an axis which is perpendicular to both of these by adding the moment of inertia about these two axes. So I've taken one example. Before taking one example, I have done, suppose, okay, a rigid body. Okay, if I take a rigid body in such a way that the moment of inertia about an axis of its is equal to the sum of the moment of inertia about two other axes, and these axes are nothing but mutually perpendicular to each other, then we have to show that the body is a lamina or is a plane lamina. Now I'm taking ABC to be the moment of inertia of a rigid body about the x-axis, y-axis, and z-axis respectively. So I'm taking here A, B, and C to be nothing but the moment of inertia of the rigid body about the x-axis, y-axis, and z-axis respectively. So by the perpendicular axis theorem, we have C equal to A plus B. Or this condition is given already. The moment of inertia about one axis is equal to the sum of the moment of inertia about the two perpendicular axes. So it is given already in the question. So we get C equal to A plus B. So we have summation delta m x square plus y square equal to summation delta m y square plus z square plus summation delta m z square plus x square. So if you multiply this, so everything will be cancelled. We are left with only do some integration. Z square delta m is equal to 0, but delta m cannot be 0 and 2 also cannot be 0, so we are forced to have z squared is equal to 0. So we got this z squared equal to 0, so we get from here z is equal to 0. So that shows that since z is 0, means it lies in a plane, means only xy coordinate is there, so it lies in one plane. So that why the given body, rigid body, is nothing but it is a plane lamina. Now using this theorem, I'll explain you one question about this. Suppose, okay, so by using the above theorem, we have to find the moment of inertia of a rectangle about the z-axis at its corner. So we are trying to find at this corner. So moment of inertia about the x-axis, we know it is about at its corner is 4 by 3 mb squared, and moment of inertia about the y-axis is nothing but 4 by 3 ma squared. Then by using the perpendicular axis theorem, so moment of inertia about the z-axis will be nothing but a plus b. So we have here 4 by 3 mb squared plus 4 by 3 ma squared, so that is nothing but 4 by 3 m a squared plus b squared. So that is the moment of inertia about the z-axis. Thank you.